So next up, we have the nicest people to work with, yet they're also the meanest people for bugs. So please welcome Madhuri and Nihao.
Again? Okay. Uh, Hello, everybody. My name is Nihal, and I'm going to talk about testing concepts along with Madhuri, who is also QA. And I'm part of the Catalyst team, and Madhuri is part of the user journey team. And we work together to ensure testing is done on the website as well as the app. So our responsibility is to find defects and bug the developers with the bugs. So today we're going to talk about 7 testing principles. I'm going to talk about some basic testing concepts, and then I will hand over to Madhuri, who is going to talk more in depth about the 7 testing principles. So what is a software? Well, since we are all software engineers, I know everyone knows this definition, but I just wanted to touch base about it, saying that it's a set of instructions or a program which instructs a computer to do a task. And softwares are used in all domains. Let it be in fashion, let it be in entertainment, let it be in banking, let it be in healthcare or insurance or media. And every software, if while you're using a software, you expect an output. And for that output to be accurate, if you want the output, it should be accurate and it should be correct. But what happens if the software is not working as intended and it's failing? So there are consequences of a failure. Well, software that does not work correctly can lead to many problems like loss of money and time, and it can also cause reputation of a company to go down, and it can also cause injury or death. This is very exclusive for critical systems, like if you're into healthcare and if you have a particular application which does some analysis based on your inputs, like for example, your blood pressure and your sugar rates and stuff like that. If it doesn't give you the right accurate information, it might prescribe you some wrong medication and it might result in death or vice versa. And for example, I can also give an example for the reputation of a company to go down. Say, for example, John is a user who is interested in buying the latest mobile, which is out yesterday. And he's on a popular website, which is currently having loads of promotions and sales, which would actually help him save loads of money. And while he's on the website, he liked a product and he's added it to his wish list, and he's in the process of checking out. And while he's doing that, he wanted to quickly read through the product description. And while he's reading through the product description, he found loads of grammatical errors, spelling mistakes, and punctuation marks going here and there. And that really put him off. And he decided to not continue on the website because the website looks unprofessional. So a defect like this, which is pretty minute, sometimes we are ignorant. We ignore such kind of things, like we don't need to worry about the copy. But that is also a defect which can also lead to the reputation of the company to go down. So why does software fail to work? That's a question that many of us have. And the reasons can be many. It can be like you have time pressure. There's time pressure from the management, or you have pressure from the client that you need to do it. So we tend to do something which we are not supposed to do. We don't check it thoroughly, and that can cause a software to fail. And it can be because human beings are fallible. We tend to make mistakes. We are not perfect. As that says, it says nobody is perfect. And it can be because you have someone in your team who is inexperienced and he doesn't know everything. Or like the technology that you're using might be pretty new, or he's fresh out of college and he's trying out things which may not be right. So that might cause the software to fail as well. Or it can be because you're working on a project which is very complex. You need to have a thorough understanding of the client requirement, the user requirements. Even even the slightest wrong requirement which has been documented can lead the developers to code something which may not be the right the expectations of the client, and it would end up in a software to fail. So I can say, I can sum it up saying that mistake, which is an error by a human being, can cause a defect in the code, and that particular defect in the code can cause the failure in the system. But I want to put a special note here. It says that, I mean, not all defects in the code would not result in the failure of a system, because a system would expect an input, and if you put an input, there would be an output. So if you put a specific input, it might cause a failure, but if you put another input, the system may not fail. So it is, again, depending upon the type of input and the output. So mistakes made by human cause defects in the code, and it causes the failure in the system. The next thing that I want to cover is, why is it important to test? Well, we all are working in software development, and there are many reasons why we need to test. But I'm going to talk about the major objective, the main 4 objectives of testing. Testing is basically important because you want to prevent defects. Testing is important because you want to find defects. Testing is also important because it helps you aid decision making, especially for the stakeholders who want to release something. If they would depend upon the results of the test to make a decision whether they want to launch or not launch, depending upon the output. And also, it helps in gaining confidence in a software. So if you want to release something, if you have spent some time in testing it, you definitely gain confidence that, okay, I've done my tests, I've tried different edge cases, I've done this and that. And if you see the system is performing as expected, you gain confidence, and then that would actually help you in releasing this even further. I'm also going to touch a little bit about testing activities. Basically, there is a common misperception that testing is only of running tests, and that is basically executing the software and checking for results. But testing is beyond that. If you look at the image, it's like an iceberg. You just see what we do, which is testing the application or the software. But we also have the other activities which are part of the test process, which includes test preparation and also test planning, where we basically sit down and understand the requirements, put the test cases together, and try to think about different edge cases which we can potentially test, and also create test data which would help in testing the application even further. You might be wondering, what is shift left? Well, shift left is basically something which was introduced based on the agile model, where the testers are involved in the testing process very early in the software development life cycle, where testers can be involved in the planning and design stage. They can also be involved in the development and build stage. Testers would definitely be involved in the testing stage. They would be involved in the testing phase as well, which is when the software is ready to deploy and release. And we would also be involved in testing after release as well, to ensure that everything is working as intended, and after it goes live, there are no particular bugs on the live or production side as well. So basically, shift left is nothing but it would help in increasing our test coverage. It would also help us in help the company as well as the team in cost effectiveness, because we are involved very early in the process. It would help save time as well, because you're not spending only the last part of basically, while the testers are involved if they're only involved in the last stage of the life cycle, you would only be given little time, and it would not help us complete everything. But if we are involved right from the beginning, we have more time to test the software, and we are able to quickly identify bugs and remove them quickly. And it also helps in team bonding, because you're working closely with the product manager, you're working closely with the developer, you're working closely with the design team. It helps in team bonding as well. Because a defect can arise at any point of the software development lifecycle. It can happen at the design phase, it can happen at the development phase, it can happen at the testing phase as well, and definitely can happen on the live site as well. And it's always better to find a defect as early as possible because it helps in all these benefits that I just mentioned.